Good morning and a very warm welcome to NUS ISS Learning Festival 2025, where we are set to spark ideas, inspire innovation, and empower transformation. In its 10th edition, this year's Learning Festival is themed Always Learning and Always Leading in the Age of Artificial Intelligence. Today marks the continuation of the virtual segment of our Learning Festival month, following a wonderful in-person Learning Festival Day held on Friday, 5th September 2025. My name is Alexandra and I'll be your MC for today. Do note that our entire event will be recorded and is best viewed on a laptop or desktop. If you have any questions, please pop them into the chat box during the Q&A session later. In today's session, titled Leading Modernization and Resilience with Confidence, we focus on leaders and specialists driving IT modernization and resilience initiatives. To begin, it is my pleasure to introduce our first speaker, Mr. Goh Boon Nam, Head of Digital Academy Services at NUS ISS, who will be sharing his insights to set the stage for today's discussion. Boon Nam, please.
Welcome to this talk and panel discussion on modernization and resilience. We will start first with the topic of modernization. What is modernization? Why is it important to get right? Let me explain by this example. TSB is a bank in UK that is like POSB in Singapore, a bank with many branches across the country that has the general public as its customer base. In 2022, it tried to modernize by a big bank cutover in April. As you can see from this news article, it went very badly with problems in all its services. This were not fully resolved until 8 months later, and it affected most of their 5.2 million customers. In the end, the bank was fined 49 million British pounds, and the CEO, not surprisingly, also had to leave. What do you think happened to the team that managed this digital modernization? The photo on the right shows some key members of that team having a champagne celebration on the day of the cutover, which is now obviously overly premature. I would think they did not do well if the CEO had to leave. Hence, it is important to know why modernization is difficult and how to cater for it. So, why is modernization difficult? On the slide are some of the common challenges. Serial number 1 is that legacy systems tend to be black boxes. What this means is that no one knows what the inside of the existing system is doing. It's just a black box. This is usually because the original team from both the user and the IT end has left. Also, any documentation is out of date or not existing at all. After the black box problem comes serial number 2 problem of the scope and size. Legacy systems can be very old, maybe 5 to 10 years or more. And each year of their life, they can perhaps have 10% new functions added in. And so what you get after 10 years can be double the size of the original system. So doing a modernization becomes more challenging than just doing a brand new, smaller system. The worst thing is that different user groups have customized the same process in different non-standardized way, and so it becomes even more complicated. Hence, it is already challenging to just move existing functions to new systems, but users want more. So number 3 on the slide shows that users want new as well as improved functions within the system. In addition, externally, the system should work well with other systems. Example, to interface data to and fro so that there's no need to manually key it in and to tap on single sources of truth. We move on to number 4 challenge, which is that of the boiling frog syndrome. The story is that if you drop a live frog into very hot water, it would immediately jump out. But if you put it in a pan of room temperature water and slowly heat it up, the frog will not realize and continues sitting inside until it gets bored to death. Legacy systems are the same because it slowly degrades in terms of poorer performance, functionality, security, and flexibility. And by the time it becomes so bad that it needs to be changed, it is already too late. System can crash due to high business load, hackers manage to break in, etc. Okay, so moving on, number 5 is the problem of modernization, where unlike a simple clean greenfield project done from a clean slate, you have a brownfield project to replace a heavily used ongoing legacy system. This is like having a propeller plane already flying with many passengers on board, and you have to convert it to a jet plane while it continues flying. This is super complicated and with additional issues highlighted in serial number 5 sub-bullets, such as dirty data to migrate. Number 6 is the ongoing system will always have change requests. And now you have the additional problem to not only implement in the legacy system, but also in the new system. Finally, when a new system is launched, there is also the risk that it is not built to be sufficiently resilient. For example, when there's a high volume of transactions, the new system becomes slow. We will cover this in the next section on resilience. Now knowing that what can go wrong and the issues that cause modernization problems, what then is an example of modernization done right? For this, the Spanish seems to be also able to provide a positive example. For the TSB negative example earlier, it was a Spanish bank, Sabadell, that bought over TSB and carried out the failed modernization project with its big bang cutover. For the positive example, it is also a Spanish bank, this time Santander. In Santander's case, they did not do a big bang, but instead did progressive cutover as well as made use of many best practices. As a result, they became the first major bank to operate 100% in the cloud. They are so advanced in their modernization that their collaboration with Google on one of these best practices, basically automated parallel testing, became a new product for Google. So, knowing the challenges of modernization and knowing that they can be overcome, what then is the secret of good modernization? Is there a simple magic bullet? Unfortunately, no. It is a lot of hard work, but at least if all this hard work is done, the chances of a successful modernization will be high. This hard work starts with step A. So, this is an important step, as it is only after many years that you have a rare chance to modernize a legacy system. Hence, it is a valuable opportunity to ensure that it fits into an overall modern, efficient, and effective architecture that integrates all the systems in the organization well. To do so, you need to have a good idea of what you want that future organization architecture to be like. Hence, you need to design that architecture first. Step B is then to address the serial number 4 boiling frog syndrome. To do so, we need to regularly review the portfolio of all the legacy systems in the organization to identify which ones are in the need for modernization. This will ensure we can kick off the modernization in a timely manner and not wait until the frog gets bored to death. So step A and B are done at the organization level. Step C itself is where it is done at the individual application level, when we start into its modernization. Step C is important in getting a good start by having the right sponsor, steering committee, and business and IT representatives. Also, having them understand their roles and responsibility and equipping them with the necessary skills. Step D then starts to control the change requests, which is item 6 in the challenges to modernization. Step D is to control the change requests so that for legacy system, only those worth doing until its end of life will get done. The rest will be put into the backlog for the new system. At the same time, those changes to be done in the legacy system need to be synchronized to also be done in the new system. Right, we move on next to step E. This is in the second row here. Basically is to address the challenge in serial number 1, which is the black box problem. So we do not know what the legacy system does, and hence we need to start to interview the users, perhaps even examining its code and looking at the inputs and outputs to try and figure out what the system is doing. All this will help, but you will still not get the full information. And so later on, I will explain to you the step K, which is parallel testing, which will help to ensure that you catch any gaps that you have missed out. Okay. Next, we move on to step F, which is to standardize the work processes in the organization. Earlier, I indicated that over the life of the legacy system, a lot of the processes will become non-standardized and there will be many variations. So there's a need to sit down with the users to come to an agreement on standardization, and after that, the improvement for the new processes. With that done, we can move on to step G, which is to design the modern system that incorporates all this standardization and improvement, and at the same time aligns to the enterprise architecture that we mentioned earlier in step A. This will allow the new system to benefit itself and the whole enterprise from the improved integration with the other systems. With step G done, you will have the vision of the end state that you want to achieve with the modernization. However, that is the jet plane that we talked about earlier. You still have to figure out how to transition from your current legacy propeller plane to the jet plane while the propeller plane is still flying in the air. Perhaps we change one of the engines from the propeller to become a jet engine, while the other propeller engine still keeps the plane flying. There are equivalent tricks similar to this in the IT world that will allow progressive cutover with minimal disruption and reduce risk to ongoing work. You will need to have your solution architect work with your users to come to an agreement on such transitions. Just be aware that the total effort for all this is much more than in just coming up with a single new system from scratch. But the effort is well worth it to avoid prematurely drinking champagne and then getting fired. Okay, next step is step I. This addresses the challenge 5 of brownfield sub-bullet on dirty data. Okay, we will need to study the data to know where is it dirty and to start the cleaning process as early as possible to discover what we might have missed out and to address all this by the time of the actual migration. At the same time, we also start on step J, which is developing the actual code for the system. And if you do it correctly using proper DevSecOps process, This will allow you to have high productivity and quality. This comes from DevSecOps methodology of having iterative test-driven development and having automated testing and progressive release. So all this will help to manage the risks. Step K then ensures execution of the testing that will include parallel testing, which is critical to ensure that the new system works exactly like the existing legacy, at least for the initial phases. Subsequent phases can then roll in the improvements that cater to the challenge of improved new functions in Bullet 3. Next, for step L, we prepare for each phase by training the end users and carrying out other relevant phase rollout preparations, for example, update of their operational SOPs, etc. Step N then executes the transition and data migrations plans for that phase. After the migration is executed, in step N, we will then do a post-cutover verification to ensure that everything works before opening up to the public. There should be arrangements made for hypercare, which is higher level of support by IT and the expert users during this initial teething issues period. Subsequently, AAR should be done, after action review should be done to see how the next phase can be improved before moving on to iterate and carrying out the next phase. This slide gives a high-level overview of how the modernization challenges can be addressed systematically. Let's now move on to challenge 7 on resilience. Right. Resilience affects both modernization as well as any existing system. We start with what can go wrong if resilience is bad. Note that we do not cover cybersecurity resilience here, as it is a specialized topic deserving its own talk. For the non-cybersecurity resilience in this talk, we are covering 3 types. The first is downtime. One impactful example is this one from the US, where in January 2023, all flights were halted due to a system downtime. That system was the NOTAM system, which is basically a system for notices to airmen. All pilots need to read the notices in the system to plan for their flights, so that they know of any issues along their flight path. With the system down, US Federal Aviation Administration had no choice but to stop all flights rather than let the pilots fly without knowledge of issues along their routes. The next resilience issue is that of poor performance. Many of you may have personal experience of this, or have heard similar from your family or colleagues. When the Taylor Swift concerts in US and also Singapore were open for booking, the surge of transactions could not be handled by the system and caused problems and frustrations. It was so serious that the US Senate even brought Ticketmaster CEO in for questioning in the Senate hearing on this issue. I'm sure most of you will know of the grilling that the US Senate hearing can have on a CEO. You probably have seen the one they did to the Singaporean who is the CEO of TikTok. So it is a type of experience most CEOs don't want to go through. The final type of resilience issue is that for output errors. This example is again from the US, this time from its education department. As can be seen, in 2024, there was massive miscalculation of student financial aid that affected hundreds of thousands of students. Again, the US Senate requested for a hearing on this and expected the Education Secretary, who is basically the Minister of Education, to answer for it. So why is resilience so difficult to achieve? These are the challenges. Basically, IT systems, especially the large ones, are immensely complex with millions of lines of code and thousands of components with lots of possibilities for bottlenecks and single points of failure. Making it worse is the business environment that demands quick, constant change and improvements to the systems so as to keep up with competitors and to meet changing customer needs. All these rush jobs lead to accumulation of tech debt, such as poorly structured code and poor design. In addition, when your business is fortunate to be successful, you also get hit with large transaction volumes and demand spikes. Lastly, with your customers now using services like Shopee, Netflix, etc., they expect your organization's app to be similarly resilient, which only adds to the challenges that you face. So, an example of an organization that rose to this challenge is Netflix. Like many organizations, it also had major resilience issues, especially in 2008, where it was down for 3 days, which I think you will definitely find not acceptable nowadays to be away from your K-drama for such a long period. This occurred again in 2012, but luckily for only 7 hours, which is also unacceptable by today's standards. After that, Netflix got very serious on resilience, such that by 2013, it was able to roll out a popular new series to all markets internationally without any issues. They did this firstly using best practices already in the industry, for example, cloud load balancing, auto scaling, etc. But beyond that, they constantly innovated and created new improvements. This included new best practices such as chaos engineering, which they introduced to the industry. They also created their own technologies, such as Open Connect appliances, to cache their popular videos in regional caches so that you can immediately access the hottest new K-drama without having to go all the way back to their central database to access. They haven't stopped at all this at these accomplishments, but continue to learn and innovate. So, what are the lessons we can learn from the industry to address the resilience challenges? Again, is there a magic bullet to solve all our issues? For those of you who have some experience in this area, you probably know the answer is that there's no single magic bullet. It is hard work to constantly ensure everything is done right and constant risk management to mitigate and cater for contingencies. It is also a life cycle approach that starts from define. This is the beginning where we need to set the right expectations by working with the user to define the required SLA. The user must understand the trade-off between SLA and cost efficiency. A higher SLA will mean higher costs. Once they set an acceptable SLA and associated costs, they need to set appropriate requirements that allow the SLA to be achieved. For example, balloting to spread out demand rather than first come, first serve. They also need to define appropriate error budget to fix tech debt, such as system bottlenecks, so that these do not build up and increase risk of resilience issues. Next is design. Besides designing for the functions of the system, the designers also need to design for it to have high uptime, high availability. They need to ensure that it can recover fast and if it goes down, and they also need to ensure fast response, system response time that can keep their customers happy. After design, we need to build and test to ensure that the design is implemented and verified to work well. Besides the normal load and stress test, there needs to be also failover tests and chaos engineering to ensure that the production environment can really cut over to redundant components where there's a need to do so. There is also need to test that backups really work, and it is possible to recover data and systems from backup repositories. Finally, to prevent errors, thorough functional testing is required, and the best way to ensure that is through full 100% automated regression testing. This overcomes the usual challenge of users finding it to do comprehensive regression testing manually, and this leaves a high possibility of bugs still residing in the system, hence the need for automation. Next, we move on to observation. Basically, once the system and functional improvements are implemented, there is a need for constant automated observation to detect any pending or actual issues as early as possible. Pending issues can be trends that indicate SLAs are going to be breached, and actual issues are SLAs already breached. The automated observation tools, especially with new AI functionality, can also be used to help identify root causes and possible solutions. Finally, we come to operations. This is where we need to manage the day-to-day work well. This includes constant risk management to identify new or growing risks and implement suitable mitigation measures and plan suitable contingency actions. This includes crisis or business continuity planning, training, and rehearsals. There will also be a need to constantly improve resilience through measures such as tuning and capacity upgrades. Finally, should any incident or crisis occur, to execute the plans well. So once a crisis or incident occurs, we need to execute the incident or crisis management plans well, including adjusting to unforeseen circumstances as they occur. In summary, similar to modernization, there is no magic bullet, but if end-to-end systematic best practices are carried out, the chances of successful modernization and high resilience will be greatly improved. Thank you, and look forward to the live QA session with you shortly.
Thank you, Bunam, for the insightful presentation. To continue the conversation, we now move into our panel discussion, where we will be joined by Victor and Chakman, alongside Bunam, to explore further perspectives on leading modernization and resilience with confidence. If you have any questions, please pop them into the chat box during the Q&A session later.
Welcome to the Q&A session. With me now is Victor Chua. He's the Deputy CEO of NUS ISS. Victor is a seasoned technology leader and practitioner with over 20 years of experience in financial services, hospitality, and technology sectors. Prior to joining NUS ISS, he served as Managing Director in Singapore's GIC, and before that, also Regional VP for Intercontinental Hotels Group. Then on my right, we have Chak. He's our Chief Stack Up Program, Chief of Stack Up Programs in NUS ISS, which caters to cloud technologies and career conversion to software engineering. So prior to NUS ISS, he was technology evangelist at Oracle and Sun. So maybe we can begin by taking a look at the questions. Maybe we take the first question, which was the one starting with step A and G. Maybe you can the question be fleshed out. So basically, I'll show that framework later to show what step A and G in detail. But basically, A and G were related to design when it comes to modernizing systems, modernization. So I think when we do modernization nowadays, a lot of the modernization is to modernize from on-prem to the cloud. And I think the question is asking what would be the key areas of cloud design to bear in mind when we do such modernizing. So for this, I think the technology evangelist is the best person to answer. Yeah, so Chuck.
Okay, thank you, Bruna. Hi, everybody. Good morning. Thank you for joining us. Okay, so one of the things when we talk about moving to cloud, of course, there's a lot of framework. If you Google, you'll find that there's a very good AWS article on 6R, like rehosting, stuff like that. But I think one of the things is sometimes you get overwhelmed because you got lots of application to move to the cloud. So it's good to define the objectives of your modernization. If you're just thinking of moving from an old machine to a new machine, that is modernization, then it can be quite difficult. But typically for modernization, you want to align, for example, with your business agility, for example, ambition. How you want to be remain competitive. So if we take that example, for example, in that case, then one of the good ways of looking is to make your application scalable, because you are hoping that you want to attract more, you want to handle more traffic. So a good example of this would be to make your application stateless. So stateless, basically what it means is that the application do not hold any internal states. It's just like going to a McDonald's where, if McDonald's like open 10 counters and we know that, one counter can serve five person in 5 minutes, then, to serve, 100 people, then we in 5 minutes, then we can just calculate, right? So stateful application allows us to do that. And a lot of legacy applications are basically stateful. What they do is that they hold states internally. And so, for example, like in an example of a shopping cart, for example, if you create a shopping cart and that cart is created in a specific instance of an application, then any interaction for a user, let's say Fred, will always need to go back to that specific instance, which sort of limits the scalability, right? So one of the things is to make the application, stateless by moving states out of the application. So that's actually one. I think the other one is also security. So today, a lot of us, especially in legacy application, the security are typically like user name, password, they're embedded tokens. So one good use is to, adopt service accounts, right? And to centralize your security so that, from one place, you provision your security, right? And so this makes your application more robust, as you move them to the cloud, right? You're hosting the application on other people's infrastructure.
I know Chuck covers a course on containers. Is container also one of the good things to aim for when modernizing?
Okay, thank you, Bruna. Yeah. So typically when you move to stateless application and stateless workload, and typically these are like web-based application, front-end application that faces customer, then container is actually a good deployment platform. It's not the only deployment platform, but typically it's a very, very good choice. If you do not know what to use, it's a good rule of thumb to use it. And also because containers are ephemeral, they can scale. If you got enough resources, they can scale almost infinitely, and you can control the scaling. And also there is a Kubernetes platform which sort of orchestrate containers, and so it allows you to have control of for scaling, for migrating, for controlling access, and those type of features. Yes.
Great. And I presume one more thing is allows some hope of portability to move from AWS to Azure in case you find the charges of one to be too expensive or whatever.
Yeah, because containers and specifically Kubernetes are industry standard. So they are provided across all cloud vendors. Yes, so that it's quite portable.
Maybe we can move on to the second question, which starts the third step mentions something. Yeah. I think the full question. Yes. Yeah. So basically, this is talking about the part on the beginning stage of the modernization project, where the project structure, resource skills become important. So what's the best way to handle this step? Maybe we can ask Victor on.
Well, thank you, Bunam, and good morning, everybody. So this really deals with, I think the keyword I would use to describe my response to this is sponsorship. All right, so for you to drive modernization, you need to have this thing called sponsorship, okay? And not just sponsorship, but cross-functional sponsorship, all right? So that is where the steering committee comes in. When you form the steering committee has to be heterogeneous or non-homogeneous, right? Whereby you have a combination of people across the business, right? So sometimes the temptation is just to have just tech people within the steering committee, but we need to stretch beyond that, right? We need to have people from the business, lines of business heads. We need data owners. We need process owners to be part of the steering committee, and that is how you drive not just sponsorship but cross-functional sponsorship, which then really leads us. So now that we have the people, the next big thing to tackle is this thing called the business case, and that is that is to me the most challenging part, right? Building the business case, particularly for things like modernization. Okay, so typically with a typical business owner or business user, to them, it's like modernization is like plumbing. It's like, it is there, it is ubiquitous. Why, if it ain't broken, why is there a need to touch it? So that is where I feel that framing is important. What often happens with technology people is that when we go to the business, we say, we need to spend a few $1 million to change the foundations, to migrate to the cloud. And as a result of that, we have all this cool functionality and all these wonderful things that we can have with the infrastructure. So be it speed, be it security hardening, and all that. But we need to try to speak the business of the language of the business. So the business thinks in terms of they think in terms of revenue, in terms of money. They think in terms of business agility, right? So the way to put it across to them is. It's not, you got to invest in this so that it becomes faster, but rather the way to say it is you invest in this, it becomes faster, and because of that, we have this thing called business agility, right? What used to take 6 weeks to do, we can now do it in 6 hours, right? And because of that, we can be more nimble and more responsive to the market, and we can go to market faster. I think that makes for a more palatable conversation with our sponsors. The second thing really is education. So often than not, people would say, hey, if I were to save this money by not upgrading this piece of hardware, I would be able to save a few $1 million. Okay, but what they do need to recognize as well is that there are things like total cost of ownership that we need to be aware of. So there's a lot of there's enough data out there that shows that if you were to keep aging infrastructure for a long time, the cost of maintenance and the cost of operating exponentiates. All right, so it doesn't plateau, it doesn't stay in a straight line, it exponentiates, right? And if you were to frame the discussion around total cost of ownership, or to educate them around the perils, of keeping something for too long, then once again, I think that would make for a more acceptable business case. All right, so really sponsorship is really the name of the game. Education, and really ensuring that it is cross-functional. The second part of the question that deals with growing necessary skills for your in-house staff, I find that I think what we used to do to great effect is this thing called the BOT model, which stands for build, operate, and transfer, right? So basically, you get on board with a vendor, you learn from the vendor during the initial phase, you try to codify the learning, and then subsequently you then wean off or reduce your reliance as we begin to mature our in-house capabilities. So that is a sustainable way of us to then build the necessary skills needed to modernize.
And I think that is part of what I mentioned earlier. Chat does some career conversions and things like that. So some people are on old technology, then they have to move to cloud technology and so on.
Yeah. So typically, what I see is like I've helped both our students and also organizations to get them on board on newer technologies. So sometimes it's easier to bring in somebody new, hire somebody new in, to work with an existing team and to inculcate, the culture. Because sometimes when we think of modernization, we think of adopting a new technology, but it's actually more than that. It's actually changing the culture of this. For example, if you want business agility and you go to typically Kubernetes, then typically you will have a pipeline, a CI pipeline that typically goes along with it. And if you don't, you just adopt Kubernetes, without this one, you won't get agility. You're just getting a new piece of shiny hardware, but without the benefits that comes with it. So it's just not the hardware, but it's also the software as well, the processes, the culture.
Okay, great. When defining SLAs with business owner, how to avoid owner wanting perfect SLAs? Victor, I'm sure this is the demand you get from your bosses in the past.
Everybody wants 100% SLA, 100% availability. I submit to all of us that is something we shouldn't commit to. It is not practicable. It is not realistic. I think what we need to do is to educate the business that availability comes at a cost. All right, and the more nines, right, the more nines you have within your availability, the more you can expect to pay. And once again, it is not linear, right? It is exponential. With the more nets you have, the cost just exponentiates. Similar with RTO and RPO, right? I mean, the lower the RTO and the lower the RPO is, the more you have to pay. All right, so we need to get comfortable with getting into a conversation on trade-offs. Okay, for the right price, you have what we would call enough availability rather than perfect availability. And obviously, to balance that, we do need to give assurances to the business that whilst we don't have 100% availability, we work very hard to have this thing called recoverability. Okay, so if something goes down, it's just the common saying goes, right? It's not a question of if, but a question of when, right? So when the systems go down, what is your plan, right? What is your plan to recover? Well, be it from backup or from the cloud. What is your plan to recover and bring it up on and or to restore the data, right? So that is something that we do need to communicate as expectation on. Somewhere in the slides it was covered, this thing about error budget, right? How it is that we need to have an error budget. I found that very useful. Upfront, agree on an error budget with the business, and then deliver and work around that and work with that rather. So I found that to be useful. But 100% availability, you're not setting yourself up to succeed.
Yeah.
Maybe, Chuck, is it even feasible in the cloud world to really have 100% availability?
Okay, so recent examples will show you that it is not feasible, right? So for example, what Victor mean by like if you have 0.9, then the cost of having 99.9 is reasonable. 0.99 gets more, 0.99. So as you have longer nines after a decimal point, the cost exponentially goes up, just to have that few extra second, for example, or minutes, of uptime. I think the other thing is also the error budget. It's actually very important. I'm coming from the engineering perspective. If you have more nines, right, then the engineering team will tend to want to make the application stable, and so experimentation will be less. So you won't have so much like innovations in your application because they're afraid to push out new code, even though it's tested in staging, but they are afraid to push out because anything can happen in production, right? So, but if you got acceptable level of error budget, then you allow your engineering team to try out new things, especially in production, to test it on your real user. I think that's the thing that I can say about this the error budget. So error budget is like in machine learning they got this thing called a hyperparameter. It's something that you tune how much you want.
Okay. Thank you both of you. Maybe we move on to the next question, which is what is the difference between traditional monitoring versus this new observability? Is this just a marketing gimmick to make you think there's something new to pay more money for?
Oh.
Maybe Chuck.
Okay, thank you. So monitoring is you know that, for example, in this specific system, you know that things are going to go wrong or things can go wrong, and so you set up an alert to monitor it, right? In observability, essentially, especially in microservices today, where there are so many interactions between processes in your system, that if something goes wrong, you do not know where to look for the error. And what observability allows you to do is this: there is no preconceived notion of saying that, oh, we're going to have a fault here, we're going to have a fault here. But when things actually do go wrong, we have probes, we have instrumentation data in place to actually query our system to say what has gone wrong. If it's slow, where is, which span or which part of the application is slow. So it allows us to be more dynamic to find out things rather than to have a preconceived notion of where things can go wrong. So doing observability is actually not you have to plan it ahead of time. It's not like monitoring where I just monitored. You have to set it up so that the applications emit the correct signals for the instrumentation, for your monitoring observability to be able to capture and read them and correlate them.
So it's more intelligent. It's not just data, but information.
Information, yeah. So that's where the an engineer can come in, or you can feed it into like an AI tool, and or a machine learning model, and that can help you to predict.
This one, Victor was previously from the hospitality industry, and I think yesterday's news was that NVS system went down. I shouldn't be, but NVS system went down, and it really affected a lot of the people. They couldn't check in and so on. What's your experience in the hospitality industry? Would monitoring observability help?
Yeah, so, well, to me, the difference between monitoring and observability is that monitoring tends to look at data points. So it's almost like a dipstick that you put into your car.
Yes.
But observability is a bit like second order thinking, where you're able to build correlations between the data points, right? So it establishes this thing called relationships, and it makes use of more data sources. So in the form of metrics, traces, logs. So it's able to give you a lot more intelligence. And I think with AI, eventually, observability paves the way for AI, for things like predictive analytics, being able to tell you when something will break down beforehand so that you can intervene and do preventive maintenance. So, observability is the name of the game. As it pertains to hospitality, that's a good example, because within hospitality, it's all about the experience. Right, it is all about when the rubber hits the road, what do the guests, what do the staff experience? So to them, they are not interested to know, whether your hard disk was down, your database was down, and things like that. To them, it's like, what exactly does it mean for me from a workflow perspective, or from what we call a jobs to be done perspective. And I think, and that is where observability comes in, right? Because with observability, you're able to do things like experience management. You're able to measure experiences. You're able to measure, what exactly the experience is for the person trying to book a website, book on the hotel website, for example, or somebody trying to use a hotel application, right? So observability would avail, at least to the, to the business and to tech departments, the impact on experience for the guests and for the staff. And that is where we can truly make a difference, So there's this thing called the watermelon effect. I don't know whether you guys have heard of it. So watermelon, right? It is green on the outside, but red on the inside. Sometimes with monitoring, it all looks green.
Yes.
It looks great. Nothing's wrong, right? But, when you cut the watermelon, it's red on the outside because, there are things that are actually not working, even though your systems are up, right? So you get this watermelon effect where, everything looks good, but, things on the ground, less than desired. Right, so we need to go deeper, and we need to really look beyond the surface and look at really what's beneath the hood, and tease out the experience or the impact on the experience.
Correct. I think maybe just a little bit more on the MBS. If I remember correctly, what I read was that it was the networking system that was down, and because of that, all the applications from check-in and all that were not able to be used. And so that's why there was the disruption. So it brings me into the issue in resilience of sometimes you are very good and you have all the redundancy in your servers and so on, but then you might not realize, and maybe it's not under your control of certain other aspects, which are the network, maybe the facilities management is the one handling it, and so on, the cabling, etc. How do you avoid such issues? Is it possible to avoid such issues of because it's end to end and then you don't control everything? Is there some way to manage it? Yeah.
Okay, I think typically so one thing that you can run, you can experiment, is to run this thing called chaos engineering, which is actually popularized by Netflix. Okay, but don't just jump head on into chaos engineering, because you need to have things in place first before you do. For example, like one of the things, the idea of chaos engineering is to do testing in production, right? As this is what they call right shift testing, right? So today, when we do testing, typically we do it sort of closer to where the developer is, during the build stage or during the staging area, right? But chaos engineering actually runs it in production, and the idea is to say that we have a resilient system, but you say you have a resilient system, but how do you know that it's resilient, right? Is to test it in production, right? And this is what chaos engineering does. So typically, before you actually get there, you actually need to have things in place, like for example, observability in place, so that when the system do fail, fail intentionally by the system, by this chaos engine, that you actually capture and see how your system is, and you discover weaknesses in your system. And also, the other thing is to give ability for your people to have drills, to have real life drills, so that when things really do fail, they already have experience. Although a bit it is like contained, but it is still a real life experience, right? And it gives people, gives your staff confidence, to manage failures.
I've actually been very intrigued by chaos engineering because it looks good on paper, but in reality, very, very, very difficult to pull off.
Yes.
Very high risk. So I was intrigued, with like how Netflix and all that, how they do it. What I've learned is that you need to be at a certain state of maturity in order to pull off chaos engineering, and it is not just technical maturity, right? It's not just the fact that you are cloud native and you are highly distributed. A lot of it has to do with you having the right tools as well, observability, and then culture.
Yes.
Right? These companies operate within an environment where they learn from failure. The failure is not frowned upon. Nobody gets punished as a result of failure, but we use it to learn. We get obsessed with failure because we have to meet the needs of hundreds of millions of subscribers, right? So resiliency becomes motivation, and sometimes you only get more resilient with failure, right? But proceed with caution.
Yes, correct.
Don't burn the house down.
Yeah.
You can set a fire to the room, but don't burn the house down.
I mean, for those of you who are interested, you can always set up a small environment and just try that non-production environment and see how it works. I think it's a good training.
So with that, leaves me to thank Victor and Chuck and our team here for this Learning Festival presentation and Q&A. And then we'll move on to hopefully you can help us to give feedback so that we can improve further. Thank you very much.
Thank you.
Bye.
Thank you.